Hello everybody. Well, in the earlier video we were seeing the different types of numbers. Now in this video we will be seeing the divisibility rule. So starting off with the divisibility rule of 2, how to check a number to be divisible by 2 or not. It's pretty simple. If the unit digit of the number is an even number, then it is divisible by 2. If the unit digit of a number is not an even number, then it's not divisible by 2. So it's as simple that the unit digit should be an even number for it to be divisible by 2. Similarly, how do you check a number to be divisible by 4? Assume that you have a 15-digit number ending with 40. Then, in this case, we would be checking the last 2 digits of the entire number, and if it is divisible by 4, then the entire number is divisible by 4. In this case, 40, the last 2 digits of this 15-digit number is divisible by 4, so this number is also divisible by 4. Let's take another number which is ending with the digits 3, 4. Where 34 is not divisible by 2, so this entire number is not divisible by 4. While we check with the divisibility test of 8, in this case the last 3 digits is being checked whether they are divisible by 8 or not. In this number, the last 3 digits are 320, which is divisible by 8, which makes the entire 15-digit or 16-digit or n-digit number to be divisible by 8. If the last 2 digits is 340, then 340 is not completely divisible by 8, which makes this 15-digit number to be not divisible by 8. If you look at it carefully, for the divisibility rule of 2, we are checking only the last digit, or in other terms the unit digit. For the divisibility rule of 4, we are checking the last 2 digits, and for the divisibility rule of 8, we are checking the last 3 digits. The one thing which is common in here is 2 is nothing but 2 power 1, so I am checking only the last digit. 4 is nothing but 2 power 2, so I am checking the last 2 digit. And 8 is nothing but 2 power 3, so I am checking the last 3 digits. So now I believe that how do you frame the divisibility rule of 32? 32 being a 2 power or 2 power 5, the divisibility rule of 32 is nothing but if you check the last 5 digits of any n-digit number, and if it's divisible by 32, the entire n-digit number is divisible by 32. If not, then it's not divisible by 32. First stop. Now that we know how to check a number, whether it's divisible by 2, 4 or 8 or any other power of 2, let's now try to see the divisibility rule of 3 and powers of 3. Starting off with the divisibility rule of 3, let me take a random number. Now, how to check whether this 5-digit number is divisible by 3 or not? It's as simple as it. Just take the digital sum of this 5-digit number. What is digital sum? Which is nothing but the sum of all the digits of the number. 7 plus 3, 10, 10 plus 6, 16, plus 2, 18, 18 plus 3, 20, 1. Now, if this digital sum is divisible by 3, then the entire number is divisible by 3. As you all can see, 21 is a multiple of 3, so it's divisible by 3. So the number 73623 is also divisible by 3. Similarly, for the divisibility rule of 9, let me take a number 75429. Now again, take the digital sum of all the numbers in this particular 5-digit number. 7 plus 5, 12, 12 plus 4, 16, 16 plus 2, 18, 18 plus 9, 27. As you all know that 27 is a multiple of 9, so it's divisible by 9. As the digital sum is divisible by 9, this makes the 5-digit number 75429 to be divisible by 9. Similarly, for the third power of 3 power 3 which is 27 also, we do the same thing. find the digital sum and check whether it's divisible by 27. For example, 98172. 9 plus 8, 17 plus 1, 18, 18 plus 7, which makes 25, 25 plus 2, 27. The digital sum 27 is divisible by 27, which makes the 5-digit number also divisible by 27. So there's one thing which is common for all the 3 powers, which is nothing but you just take the sum of the digits and check whether it's divisible by the respective numbers. Next comes the divisibility rule of 5 and powers of 5. How to check whether a number is divisible by 5? Well, this is the most simplest divisibility test among the other numbers. For a number to be divisible by 5, the unit digit of the number should either be 5 or 0. Then the entire number is divisible by 5. Now, the same goes for the powers of 5. How do you check a number to be divisible by 25? As 5 is the first power of 5, I checked only the last digit. Now 25 is 5 power 2, so I am going to check the last 2 digits of the given number, whether it's divisible by 25 or not. For example, 7525. In this number, the last 2 digits are 25. The last 2 digits 25 is divisible by 25, which makes the entire 4-digit number 7525 to be divisible by 25. 7565. In this number, the last 2 digits are 65. 65 is not divisible by 25. That makes 7565 not divisible by 25. So this goes on for all the powers of 5, like 125, 625 and so on. So for 125 you will be checking the last 3 digits of the number to be divisible by 125, and for 625 you will be checking the last 4 digits of the number to be divisible by 625. The divisibility rule of 11 is quite different from the other numbers, but it's not difficult. So let me again take a random number. Now we are going to check whether this number is going to be divisible by 11 or not. So for the divisibility rule of 11, it's quite simple that you just separate the numbers in the odd positions and the numbers in the even positions. While the numbers 7, 6, 2 are in the odd positions and 5, 3 and 2 are in the even positions. Once you separate, take all the numbers in the odd positions, add them, take all the numbers in the even positions and add them. 7 plus 6, which makes 13, 13 plus 2, 15. And again 5 plus 3, 8, 8 plus 1, 9. Now take the difference of these two numbers, 15 and 9. 15 and 9 gives you a difference of 6. Now 6 is not a multiple of 11, so this 6-digit number 756321 is not divisible by 11. Well, if you look into the divisibility rule of 11, that is quite special, but it's not difficult. So let me just randomly take a 6-digit number, 753621. Now I want to check whether this 6-digit number is divisible by 11 or not, for which I am going to split all the numbers in the odd positions and the numbers in the even positions. 7, 3, 2. Which are in the odd positions, 5, 6, 1 which are in the even positions. Now I will add all the numbers in the odd positions individually, 7 plus 3 plus 2 which makes 12, and add all the numbers in the even positions, 5 plus 6 plus 1 which is 12, and take the difference of these two sums which is giving me 0. So the difference in the sum of the even positions and odd positions, if it is 0, then the number is divisible by 11. At times, you might get the difference to be 11, 22, 33 or any multiple of 11. In that case also, the number is divisible by 11. Change the last value to be 0. Now, sum of all the numbers in the odd positions remains as 12 and sum of all the numbers in the even positions will be 11. Which makes the difference to be 1. If the difference is anything other than 0 or multiple of 11, then the number is not divisible by 11. So 753620 is not divisible by 11. Now that we have seen the divisibility rule of all the primary numbers, how do we frame the divisibility rule of numbers like 6, 12, 15, 22 and so on? Now there is no direct divisibility rule for 6. So what do? I just write 6 as 2 into 3. So if a number is satisfying the divisibility rule of 2 and 3, then the number is divisible by 6. Similarly, for 12, I am going to split it as 4 and 3. So if a number is satisfying the divisibility rule of 4 and 3, then the number is divisible by 12. Similarly, for 15, it should satisfy the divisibility rule of 5 and 3, and for 22, it should be satisfying the divisibility rule of 2 and 11. So in this manner, you can frame the divisibility rule of all the other numbers except for the prime numbers. So now that we have come to the most confusing divisibility rules, which is nothing but the divisibility rule of the prime numbers. So let me say, take some prime numbers like 7, 13, 17. And now this shortcut or trick might help you to find or frame the divisibility rule for any prime numbers. So starting with 7, I am going to write the multiple of 7 that ends with 9 and 1, and I will be doing the same for 13 and 17. So yes, the multiple of 7 which is ending with 9 is nothing but 49. The multiple of 7 which is ending with 1 is nothing but 21. Similarly, the multiple of 13 which is ending with 9, I mean the lowest multiple of 13 which is ending with 9 is nothing but 39. Similarly, for 17 it's nothing but 119. Likewise, the multiples of 13 and 17 ending with 1 is nothing but 91 and 51. So now that we know the multiple of the prime number which is ending with 9 and 1, we are going to find a positive number and a negative number. This positive number and negative number I am just going to take from these numbers. But how? So yes, in this 49, how many tens are there? Like I can make 5 tens with 1 less, because I have 49. If I add one number to it, then it will make 50, which has 5 tens. So I will be adding some number to it and make 5 tens out of it. And here I have 2 tens completely and 1 is extra. I would be subtracting that one, then out of which I can make 2 tens. So that's the reason why I have included the negative sign over there. Similarly, in 39, I can make 4 tens by adding 1 to it, and eliminating 1 from it, I can make 9 tens in it. Similarly, for 17, in 119, I can make 12 times of 10 by adding 1 to it, and by removing 1 from this, I can make 5 tens. So that's the reason, again I have included negative signs over there. So these numbers are like for framing the divisibility rule for it. So for a number to be divisible by 7, you are going to just multiply the last digit with 2 and subtract it from the remaining numbers, and do the same until you get the single digit number. For the divisibility rule of 13, you are going to multiply the unit digit of the given number with 9 and subtract it from the remaining numbers, and repeat it until you get a single digit number. Similarly, for the divisibility rule of 17 also, you take the last digit of the given number, multiply it with 5 and keep on subtracting until you get a single digit number. But if you look at the divisibility rule of 13, it's very clear that 4 is a smaller number than 9. So multiplying the number with 4 will be pretty easier than multiplying the number with 9. So in this case, I would just take the unit digit and multiply it with 4 and add it to the remaining digits, rather than multiplying it with 9 and subtracting from the remaining digits. So let's take an example and just try to apply this particular shortcut and try checking whether it works. So let me take a number like 3443. Now I want to check whether this number is divisible by 7. So what do? As I told you, I am going to take the unit digit multiplied with 2, 3 into 2 6, and subtract it from the remaining numbers. Taking the unit digit, multiplying it with 2 and subtracting it from the remaining numbers. So I get 338. Again, take the unit digit 8, multiply it by 2, which makes it 16, and subtract it from the remaining numbers. 17 of course. So now you have a 2-digit number. It's up to your comfort whether you get it until a single digit or a 2-digit. Now I want to check whether the 17 is divisible by 7. Of course 17 is not a multiple of 7. So 3443 is not divisible by 7. So you can apply this for any n-digit number. Similarly, the divisibility rule of 13 is nothing but we do have two key numbers, +4 and -9. Either you multiply the unit digit with 4 and add it to the remaining numbers, or you multiply the unit digit with 9 and subtract it from the remaining numbers. As I told you earlier, 4 is a smaller number, so I am going to go with 4. Again I take the same number, 3443. Now the unit digit over here is 3. Take the unit digit multiplied with 4, which makes it 12. Add it to the remaining numbers. So 344 plus 12, which make it 653. And again take the unit digit 6, multiply it with 4, which makes it 24, and add it to the remaining numbers. Now it is 9 and 5, 59. We very well know that 59 is not a multiple of 13. So 3443 is again not a multiple of 13.